work. I think it's probably best that before I go any further, I'll probably just whiteboard a complete deployment for SteelFusion, and maybe we can go through some of the details at that point in time. So it's so let's use this whiteboard as the edge of the enterprise. And quite figuratively, there is a gap, or the WAN, between the edge and the data center. So if you go look at a typical edge location, what you are going to have is some degree of server. This is me trying to draw storage here. So some storage and potentially some form of backup infrastructure in each of those edge locations. Particularly if you're looking at a relatively important location, you're going to have some sort of backup there. What SteelFusion does is fundamentally go and collapse that into a single appliance that we call the SteelFusion Edge. Let's just represent that as SteelFusion Edge. And that has elements of virtualization. Here's the storage cache that I was talking about. And finally, some WAN optimization component. It's these three components that are working together in close harmony. And like I mentioned earlier, we have a head end that sits in the data center that's going to go ahead and basically think about this as an aggregator for many, many different edge sites, right? So let's just call this site 1, and you can have site 2 and many other sites as well. So think about this almost like a hub and spoke sort of a model where you have an aggregator. So in the data center, we have a component that very imaginatively that we call the core. And this core connects to enterprise grade storage. Now this could be, and we'll get into some of the details later, but as of now, you can connect this to iSCSI fiber channel or NFS-based storage. This is your primary, this is basically the final resting place for all the data that you have associated with it. So let's just try and go through a complete sort of a workflow for how you would go about trying to deploy applications centrally and to your edge location. Now, typically, if you were working in a data center, the way you would deploy applications is essentially you have a golden image, and that's probably you stored as a VMware template of sorts, and you have a template data store of some sort. And this data store may contain a number of VMs that are associated with it. With SteelFusion, what you would do is essentially create a copy of this template, right? Present it to the SteelFusion core. And then what SteelFusion core would do is essentially map, and we'll call this operation the mapping operation, map this volume of data and send it across to the edge.
Okay, and these are vSphere templates?
These could be vSphere templates. Yes, absolutely. These could be vSphere templates that are sorry.
Could is not a good word in this position, because if they're KVM templates and you're running ESXi, they're not going to work. So are they VMware templates?
Yes, today we currently support VMware.
Okay.
Yeah. So these are VMware vSphere templates. Okay. So let's start with the template. Essentially, when you map this volume, and at that point in time, it's pretty much a data store, right? It's a VMware data store that you're using. We would map this data store where this data store, let's just call this A, right? So it's A prime. So A prime is essentially an image of that same data store that you had in the data center that you are presenting to do the virtualization host that's contained inside the SteelFusion.
Okay, so does the core there behave like an ESXi host, and I can have other hosts connected to that data store, the one that has my templates?
No. So the core does not really function as an ESXi host. It purely functions as a storage broker.
So there's a... It's not what I meant.
Okay, sorry. Okay.
You've got the data store there that's got the templates on it.
Yes, absolutely.
is that data store owned exclusively by the core, or is it shared by my other ESXi hosts?
It's owned exclusively by the core.
So I have to copy. So I have to export my
Yes.
template and copy it.
Yes, this would be a copy from your gold. So you have your template store. It's a golden copy of. You create a clone of that, depending on what your favorite storage protocol is.
And
There's a single
now I've got 2 templates in 2 different places that I have to patch separately.
Yes, you can. There's. Let me get to the patching question a little bit later. But yes, fundamentally, it is 2 separate template. It is a template that it's going to become. That template is going to get converted into a live running virtual machine in the edge. So from
But if I create a template, I'm going to convert it into 12 virtual machines in 12 edge devices.
Yes.
And I'm going to convert it into 400 virtual machines in my data center in my ESXi environment. But there's 2 copies there, and,
Yes,
and now I have 2 roots.
Yes, there's multiple copies, yes. Absolutely. So at this point in time, you have a copy of this. You have essentially a version of this data store, A prime, that's living in the SteelFusion Edge. Now the virtualization host, this is purely VMware, purely a VMware operation. To VMware, though this is just a copy of the data, though it appears. Sorry, go ahead.
Is that map a push, or are you just creating a pointer and the cache has to warm later?
So it is a push, and what we do right after the push is something that we call we start pre-warming. We start warming up the cache based on intelligence that we call Prefetch. So what Prefetch essentially does is the moment you provide a template to the core, we essentially create what we call a bimap, right? And this bimap is essentially a mapping of the data, so that all the data that's associated with those particular templates. So we have file system intelligence to go and understand NTFS running over VMFS or NTFS running over NFS, where we completely go in and understand, okay, what does this, essentially create a mapping of how a file would map into a block. So we create that mapping. That bimap is essentially stored inside of this core. It's a memory structure. So when your virtualization host goes and sees this data store, it essentially very quickly knows it. You can connect to it. You can register your VMs and go and hit click power. You can go in and click power. The most interesting thing about SteelFusion is, you may have your data stores which may be tens of terabytes, maybe tens of gigabytes, not terabytes, tens of gigabytes in size, sometimes even hundreds of gigabytes. You don't need to wait until all the data is fully hydrated across the WAN. Even before all the data is hydrated, just think about very minimal bits of metadata that are associated with the virtual machines needs to be transferred across before VMware knows that it's the set of VMX. It's the metadata that's associated with it. What we then do is we've built in something that so this technology is what we call Bootover VMs. So what the Bootover VMs technology allows us to do is, and we've done this in multiple, we do this in our lab all the time, and we've done some lab validations as well. We've gone and seen a Windows VM, that's 40, 60 gigs in size, go and boot over a 3 meg link with 100 milliseconds of latency across a WAN in 8 minutes time. And we see that on a very repeated basis. So, and the only data that's transferred across the WAN is essentially just the very basic amounts of data that Windows needs to boot up. Think about this as the master boot record, and think about this as the core files that are needed to boot up a VM. And that's all that you would need to boot, to set up to essentially have applications up and running.
Okay,
so
go ahead.
Is the solution itself OS aware to know what it needs to accelerate, and does it always accelerate? So if it's Windows 2008 R2, because that's the last time I used Windows, does it say, you know what, I can basically, for lack of a better term, dedupe those bits all the way at the edge because I don't need to copy the same copy of Windows over and over again, obviously. And then second part of that question, what happens when I run into non-standard bits within Windows? So if I have some service, let's say a vCenter service that takes 180 minutes to boot up, to start, what does it prioritize those services that start as part of the replication, as part of that warming prefetch piece? So I can boot Windows, but my services may not start if I don't have all of the bits there to start the service, because there's now latency waiting for those services to start.
So I'll get the first part of the question, right? So yes, we are, most of our customers are running Windows-based applications. So we've gone and prioritized going and building techniques to optimize Windows boot-ups. We spend quite a bit of effort with every successive Windows release to really understand those patterns. So Windows 2008, 12, 16, we can go and boot those up. And the boot up times seem fairly comparable across the Windows OSs. So
and the data is deduplicated. So if I already had a Windows 2008 machine in that edge, you just have to fetch the unique blocks.
Absolutely, and that's the combination of all of these technologies working together. So when I mentioned the 8 minutes that it would require to boot, that's on a completely cold cache. You've never ever seen Windows before. It's never ever seen those sort of patterns. Even the SteelFusion has not seen those patterns before. Okay. So that's the time. But you're right. For the next boot, maybe it's a similar Windows machine. The boot up times are going to be, because much of that data is going to be cached, or at least we'll understand those patterns. It's going to be maybe half the time. And so on. You'll get some degree of benefit from the repetition of the same image coming through.
Okay.
So I think your question, the next question that you had was, if you have a vCenter service, right?
It's not just any service. So file system. So I've seen Steelheads do file servers, and file servers are pretty easy. I need Windows services, file services. I just need the files. That's kind of low-hanging fruit. So as we talk about other enterprise applications that are more business line applications, they take longer to start because they're more complex applications.
Absolutely.
Part of that starting process is getting the differential bits, the very dependencies onto the stuff. So have you guys done any benchmarking? So booting Windows and starting services that an application needs is two completely different things. I can get the desktop.
You can go and see. It's not just about trying to get to the Windows logon screen where you have to go in and log on. Yes, absolutely.
Right.
So what we are looking to go and do essentially is to provide a sense of what we call instant provisioning of applications. So the boot up sequence is something that's fairly well known. We use some additional techniques to go and make that to improve the boot up times with that. But after you've booted up, it's not as if the work's done at that point in time. So the prefetch algorithm that we have is actually what it keeps doing is it keeps track of what are the blocks that are requested. It does have like I mentioned, it is file system aware, so it understands what files are being requested, and based on that, we've developed we've developed a few techniques by which we understand whether the blocks that were served out were accessed by the applications, and based by the application in a certain amount of time. If they are accessed, then we're like, okay, that seems like a hit. Let me go and get more data of the same kind. So it goes in and pulls more data. On the other hand, if there is a miss on that application, we're like, we probably fetched the wrong bit of data. Back off on that, and let's try and get some of the other, a different segment of data. So essentially, there is some degree of self-learning that's built into that application. We've got a few different techniques that we use to go get that. I don't think we want to go and discuss all of those right now, but there's
just high level.
At a high level, that we've built in a few different variations of those techniques, and we constantly keep improving on them just to make sure that the goal here again is you don't just want to see the logon screen. You want to start running your application sooner.
Yeah, I mean, I think basically there's three categories of that machine learning, right, that Parimal talked about. So from booting over the WAN, you can imagine the SteelFusion core actually noticing and recognizing, hey, this block that was requested, that's a master boot record block, right? And I actually know what needs to happen, and we've optimized for certain boot ups of Windows and other OSs, right? The second, so that's the first class, is what's happening as that machine is booting up. The second class is making sense of the actual underlying file system. So this is a block that actually represents an inode in NTFS or VMFS. And I know that that inode actually maps to a set of other blocks for that file, right? So that's kind of, I don't need to do any generic machine learning for that. I've been noticing these things come through, and I can map out sort of at a file system level what's going on. And then the third piece would be this generic understanding of, for anything that feels still random in terms of the access, because it really does feel like random access to the block, this machine learning that's saying it was a hit or it was a not. Yeah. Those three things together allows us to do some really good things for booting up, for some common operations that the file-based prefetching can really work well, and then having a core piece that happens for any generic application.
Does that kind of address your, the sort of?
Yeah, generic. I mean, I'm thinking through some advanced use cases like VDI at the edge, so accelerated from here, managed from there. So there's deeper conversations, but
sure,
I think from the high level.
We can definitely connect a little later, but and actually we do have customers that are running even VDI at the edge of VDI applications even at the edge of the enterprise. So
you want to talk about that a little bit more in terms of the on the VDI side? I mean, at a high level,
absolutely. So
from a VDI perspective, there's actually an interesting use case where what you can do is get some of the best of both worlds. So VDI gives you this ability to centrally manage all those desktops, right? But if the WAN goes down, you're out of luck, right?
Well, it's not even if the WAN goes down. It comes from a manageability perspective. I put them in the data center because I can manage them in the data center.
Right.
But if I have data at the edge, but I don't want to manage I don't want to manage a VDI infrastructure per se at the edge.
Right.
Then I project it towards the edge.
That's exactly right.
So it's not necessarily a WAN thing. It's more of a management optimization.
Right. Exactly. Well, so you can get that management benefit. And then I'm going to boldly start saying things that Parimal may correct me on.
But you cringe before that.
You may see him cringe. But you can also get an availability benefit. So one of the things you can do is you can think of your VDI presentation server as a virtual service that you want to boot that over the WAN.
Right.
And manage all the storage out here. So that presentation server that's running with what it thinks is local storage is actually storage that's managed here. And it's actually a virtualized image of your presentation server that's out there. So if that wide area network does go down, it can actually continue to service those applications, even if it was locally available. So that's what it kind of meant in terms of get your cake too.
So what granularity is that cache at? Because if it's really a cache, and you're working at sub VMDK level, then when that WAN goes down, it's going to work fine till I access some block that isn't in the cache, which is a completely unknowable.
Right.
No, and absolutely, right? If the WAN does go down and you run into a cache miss, the behavior is completely application dependent, right?
I mean, it'll revert back to what you had if you didn't have a disconnected node. Yeah.
So it does go into that sort of gray area.
So I can't say this application in my retail store has to run whether the WAN is up or not.
And yes, you can.
Okay, so I can pin VMDKs to the cache.
You can essentially pin. It is, and the word is exactly that. You pin that volume.
Yeah,
it's associated with it.
Specifically retail.
Exactly.
No, I'm not going to close the store because somebody drove into the phone pole that has the the DSL line.
Yeah. And actually, we are actually going to, if we do get time, we will talk about a retail customer of ours. As Catherine tells me, I have 10 minutes more. So maybe we'll do a very abbreviated version of that. But yes, the point of sale systems is an application that must run. So we have customers doing that as well.
So some people think of that cache as literally that, sort of a subset of the data. But if you really truly need disconnected operations forever, all time, anytime the WAN goes down, you can pin that. And just think of that as a full logical extension of that storage. But it's not something you have to, quote unquote, manage. Because all
No,
that.
because it's a secondary, if the WAN is
Yeah.
up, it's a secondary copy.
Exactly.
It's cache.
It'll keep.
But I do want to be able to manage.
Yeah.
Yep.
It'll still take on new rights, and as soon as the WAN comes up, that continuous data protection will kick back in. You don't need to think about, oh, I got to restart my backup.
You don't have
Now,
to go and set
if
up
the WAN is down for an extended period of time, can I tell it I don't care about history and just catch up to the present?
So in an ideal, we did consider that model where we would just go and say, let's stop considering that. But what that does break is the notion of write order fidelity, right? So what you're doing, one of the things that we...
Well, I was thinking more of, the WAN came up, take a snapshot, make it current to that snapshot. I don't care about what happened in between.
So what we really want, what we do try and do is essentially provide you the ability to take snapshots of this A prime.
Right.
We do want to allow... Our idea is to try and eliminate operations and infrastructure at the edge. So we want you to have that.
I understand.
Yep.
But I have literally supported that retail store where somebody drove over the telephone pole. And they're offline for 3 weeks.
Yep.
And I don't care about every write that happened to the database over 3 weeks. I just want to bring the database up to date at the core.
Yeah. So the way you would do that,
And I don't have enough bandwidth to catch up to that 3 weeks.
so let me just illustrate to you how you would do that with SteelFusion. Somebody ran into the pole. Somebody ran a car into the pole. You've lost all connectivity. It's going to take you a while before you have any infrastructure back there. So this site is gone.
Right.
But what you have is this copy of data. All the writes that were being written to A prime here, right, within a matter of seconds, are essentially available at the true source, the true resting place of data, which is back in the data center.
No, the connection to the data center is dead.
It's dead, but before it was dead, there is some amount of data, right? So yes, you would lose some data that's here if the site is down.
No.
Okay.
You got it
So the
backwards.
use case is
You-
business continuality at the edge if I lose connectivity.
Okay.
So I've lost connectivity. I'm still in business because the application is still up.
Okay.
So when the link comes back up, the argument is that so much data has been generated
Yep.
that I'll never get back in sync.
So two things to that. One is we have two ways in which we try to avoid that problem. One is we maintain what we call the write reserve of data. So there is a write reserve that is built in. So if we go and tell you that there is
The problem is that, that the write reserve is a terabyte of data, and I have a 1 megabit DSL line.
Yep.
I generate 800K bits per second under normal conditions. It's been down 3 weeks. It will never catch up.
Yep.
I want you to say, throw all the history away, bring the data center to current, and I don't care about the intervening.
No, that is something that we are looking to go and implement in a subsequent version.
That's all you needed to say.
Absolutely. That is a use case, where you are basically running across a super constrained link that's down for a while. That is something that we are looking to implement. Rob, when's that coming?
Yeah, it's,
Input
CDP is great, but sometimes all I need is now.
That is the
warp.
out. That is what
Yeah.
you go and get out of. That's the get out of jail card essentially.
Yeah.
Yep.
How much
So-
can I pin?
I'm sorry.
I can pin a VM to the branch, but
You
that's just one. If I got several,
Yeah, how big can the cache be?
So we support a variety of different appliance sizes. So it's basically
How big is the
it's a
cache
size-
in the biggest appliance?
That's roughly 15.5 terabytes.
Okay.
So, and again, that is the size of the cache. So that's but it could represent a much larger thing if you're running in cached mode. If you're running,
But it could be
one-to-one
12 terabytes of pinned and 3 terabytes of cache for other things.
Because you want to go in and provide some degree of write reserve, it's a little less than that.
You can pick which lens you want to pin.